Saxon's Trig, lesson 87, is about sum and difference identities and then tangent identities. So in part A, the sum and difference identities, you need to know, and it's a series of formulas that I would definitely write down to use as reference as you are memorizing them. So this is where I have two different degrees that are being added together. Now I wish, because it would be nice, that you could just say sine of 30 plus 45 degrees. Okay, well that means I can make that 75 degrees and just do sine of 75 degrees and have my answer, but it does not work that way. So the formula when you were trying to do sine of A plus B is sine of A, so it starts with this one, and then it goes to cosine of the B. Because it is plus, you are going to keep a plus, and then you're reversing so that you do the cosine of A multiplying with the sine of B. I don't have nice little ways to memorize it, but that is the first formula. Here's the next one, so maybe you can begin to find ways that work for you. Sine of A minus B. That is the sine of A multiplying with the cosine of B minus cosine A sine B. Now, so far you're thinking, okay, I probably have found a way to do that. All right, well, here's cosine A plus B, and then you can kind of see how this changes things. At least on this one, it's cosine A, cosine B kept together. And if this is a plus, you're using a minus here. It's exact opposite of what you did here. With signs, you kept the signs the same. And then sine A, sine B. I find that one a little touch easier to memorize, but cosine A minus B is going to give you cosine A, cosine B plus, as you expect, sine A, sine B. So there are the four new formulas. Now, the book does review that tangent means sine over cosine, and we have the major fact sine squared plus cosine squared equals 1. So it does review those here, and it says as you're proving, you might need to use those other formulas to kind of help get you there. All right. It does want you to prove why these formulas work, but first, example 1 merely says, simplify the sine of theta plus pi over 4. So I'm going to follow the formula for sine of A plus B, and we're going to do sine of theta, because that's A, cosine of pi over 4 plus cosine of theta and sine of pi over 4. Now, the pi over 4, I don't instinctively necessarily know what it is, so I'm going to change it over to degree by making the pi cancel and use the 180. That's the memorized conversion fact. And 4 goes in here 45 times, so I know I'm graphing 45 degrees. Which means 1, 1, and root 2. So for the cosine of 45 degrees, ca, I want that to be adjacent 1 over root 2, and I know I want to fix that in a second, plus, and the sine of pi over 4, opposite over hypotenuse, is the same 1 over root 2, just because it was 45 degrees, and the sine of theta, I didn't do anything with it, or with the cosine of theta, because I can't do anything with those. They're just stuck there with their thetas. So once you fix these pieces and put them in front, because coefficients should be in front of other things, you will have your answer. So when I fix that, that becomes root 2 over 2, because you're multiplying by root 2 over root 2 equaling 1. And then sine of theta. Now, what they chose to do in the book was say that since both of these have the same front number, let's factor it out. And they just kept plus cosine of theta here, and they said this is the simplified answer. Whether you write it pulled out separated or whether you write root 2 over 2 sine theta plus root 2 over 2 cosine theta, either way, same thing, acceptable answers, not a problem. Okay, now here's another, in example 2, another reason why we have these formulas to accomplish things with addition. So here you saw it was because we had a theta, not a degree to work with. In example 2, it says, find the answer for the cosine of 15 degrees. Now that is certainly not a memorized triangle 30, 60, 90 or 45, 45, 90 because it's 15. So what they did was they said, let's use the fact that 15 can come from 60 minus 45. Things we know, oh, that'll give me 15. So if I'm minusing and it's with a cosine, I'm going to use this formula here. That's another reason why we have these. So we're going to fill in cosine of 60 multiplying with cosine of 45, and I'm going to put that in parentheses as well, plus sine of the 60 multiplying with sine of the 45. So now we filled in using the formula, and we're going to graph the 60 and the 45. 45 I'm going to use from up here since we've already done it. So I'm just going to graph the 60, opposite the 60's root 3, adjacent's 1, hypotenuse is 2. All right, so cosine of 60, ca, adjacent over hypotenuse, cosine of 45, ca, adjacent over hypotenuse, plus sine of 60, so opposite over hypotenuse, multiplying with sine of, which is 1 over root 2 again. All right, now I can choose to fix this and then multiply or multiply and then fix. Doesn't really matter. I'm going to multiply then fix. So at the moment, this is 1 over 2 root 2 plus root 3 over 2 root 2. And since these are already common denominators, I can choose to go ahead and put that together. 1 plus root 3 over 2 root 2. And now I can choose to get rid of the root 2 by doing same thing top and bottom. And again, the order that you do that really doesn't matter. It's what you see that works best for you. So root 2 times 1, root 2. And root 3 times root 2 is root 6, all over. Root 2 times root 2 is a 2, times this 2 that's already here is a 4. I can't reduce any of the outside whole numbers, so I wrote it as one fraction. Oh, yes, they wrote it as that too. I thought for a split second they had it as two different ones. They don't. Okay, example 3. This time we're back to doing a cosine of a theta plus pi over 2. And because it has the theta, that's why this formula is helpful to use. So we're going to follow cosine A plus B. Cosine of theta, cosine of pi over 2, minus sine of theta and sine of pi over 2. So our pi over 2, we're going to change, get rid of the pi, use the 180. 2 goes into 180 90 times, so I'm actually graphing 90 degrees, 0, 90, so that's on this line, fake triangle that doesn't exist. I am going up, but I'm not going over, and that will match with a hypotenuse then of 1. So cosine of theta, can't do anything with it, multiplying with cosine of the 90, so ca, adjacent over hypotenuse, that's 0, so that's going to be thrown out completely, minus sine of theta and then sine of this, so opposite over hypotenuse, 1 over 1, that's basically 1. So when I multiply, I don't really need that 1 anymore, so it's just negative sine of theta is the only part to keep. Okay, tangent identities in part B. They remind you that tangent is sine over cosine. And then rather than, so again, they're not choosing to do the proof of these until another lesson. They're just saying here, kind of get used to using them. But with tangent, they do more of a proof of them. And it's going to take space. I think I'm going to shift over here. All right, so example 4 says develop an identity for tangent A plus B. So I can't just give you the formula. They want you to prove it out. So tangent means sine over cosine. So what you're going to do is the sine of a plus b over the cosine of a plus b, because tangent means sine over cosine, and we're matching this a plus b. Now, you need to pull the long formulas for what the sine of a plus b and the cosine of a plus b was. So I'm going to write it down here where we've got more room. So sine was sine a cosine b plus cosine a sine b over cosine a cosine b minus sine a sine b. All right, so here's those two formulas written that were provided earlier in this lesson. Now this is just a mess. I don't see anything instinctively that I can do. I can't pull a sine out of everything. Well, I might be able to pull a sine out of something, but I can't do that down here, so it doesn't help. Same thing with cosines, doesn't help. So everything I look at just kind of stymies me because there's nothing I can do. So what you need to be told to do this development was mathematicians just decided, somebody in the past decided, what we're going to do is we're going to take this very first term in the bottom, and we're going to divide all four parts by that term. Don't ask me how they came up with that, but that's what they did. So we're going to write cosine A, cosine B underneath everything. So picture the same thing under here and here, forming four now even more yucky looking fractions. Okay, so this one picturing sine A over cosine B. Nothing I can do with the sine part, but the cosine B over the cosine B is going to cross off because they're multiplying together. I'm allowed to do that. So ultimately, what is that leaving me with? Sine A over cosine A. What is sine A over cosine A? Sine over cosine is tangent. So this top piece has gone to tangent A plus, now picture this one over this. So cosine A is going to cross off, leaving the sine B over cosine B. So that is tangent B all over. Now this one, because we did the same thing, top and bottom, it gets to a 1, the minus sign in between. And then what happens here? Nothing cancels off, but I have a sine over cosine with A and a sine over cosine with B. So that turns back to tangent A multiplying with tangent B. Oh, look, there's the formula for tangent A plus B equals this one. Now, example 5 says do the exact same thing with tangent A minus B's. Now, rather than going through this process again, because it's going to work the same way, you're going to write those formulas out top and bottom. Whatever this piece is, you're going to divide all four parts by that. And so the tangent of A minus B ends up giving you tangent A, mix my N and my A up there, plus tangent B all over 1 plus tangent A tangent B. So what is the only difference between these formulas? Oh, fiddlesticks, I wrote plus and I meant minus. There are two changes, the signs here and here. So this one goes to a minus and this one goes to a positive, exactly the opposite of what we had from before. Yep, so here is that one. Those are the two tangent formulas that I would write after I had written the other four. I would definitely make sure that I had those two in there. Then they finish up the lesson with example 6 where they say, find the tangent of theta plus 45 degrees. That's this one, which was this formula. So we're going to do the tangent of theta plus the tangent of 45 degrees over 1 minus tangent theta tangent 45 degrees. So 45 degrees, graph's first quadrant, 1, 1, root 2. Tangent is TOA, opposite over adjacent, so that's 1. So this remains tangent theta plus 1 over 1 minus tangent theta times 1, which doesn't make any difference. I cannot make any changes to that answer, so that is all we need to finish the problem.